What is the first thing that you learn about mathematics? Have you ever thought about that? So today, what we're going to see is about numbers and the hierarchy or the different number sets. Let's go. So, what is the first thing that we learn, like when you're a kid, and the first thing that you learn is how to count. So this is the first thing that we learn, how to count. So you start learning the numbers we used to count, and numbers we used to count are, the numbers we used to count are 1, 2, 3, etc. Right? So the numbers we used to count are natural for everybody. It's the first thing that you learn. So this is why we call it the natural numbers. These are called the natural numbers. And with the natural numbers, there are many things that you can do, like for example, adding, because you can add any natural number to get another natural number. And for example, you can multiply, because if you multiply two natural numbers, you're gonna get another natural number. However, there's a problem when we start subtracting numbers. Because with addition and multiplication, everything goes fine. But if you start subtracting numbers, there are two different situations. The first situation is what happens if you take 1 minus 1, the same natural number subtracted by the same natural number. As you can see, this is not a number you can count. You don't have it in a way to count because it's 0. And 0, it's going to include you into a new number set. And it's the set that includes not only the natural numbers, but also the 0. This is called the whole number system. Now, the question is, what happens with the subtraction when you have numbers that are greater? So for example, 2 minus 3. What happens if you subtract a number that is greater in absolute value than the minimum? What you can do? It happens that you cannot use natural numbers or whole numbers. And this is when it appears the negative numbers. So in this case, will be -1 or opposite 1. So you have the opposite numbers of the natural numbers, including the 0. This is what we call the integers. The integers are all the numbers, all the natural numbers. Sorry, let's write it in this way. You have all the natural numbers, you have the 0, and you also have all the negative or the opposite numbers. This is what we call the integers. So far, what we have found out is that we have 3 different sets. The first set is related to counting, when you count. So you have the first set, that is the natural number set. The second set is when you include in subtraction, the subtraction, for example, 1 minus 1, 2 minus 2, the same number subtracted, and you include 0, so you have the whole numbers. And finally, what happens if you include the subtraction of any natural numbers? So you have the integers, because you need the opposite of the natural numbers. So this is what we have so far. But if we continue learning in our approach, we learn how to add, how to multiply, how to subtract. So now it's natural for us that the next one is going to be what happened with division. Could we use this set of whole integers or naturals for divisions? Could we use it? So for example, if you have 10 divided by 2, okay, it's gonna give you 5, so 10 divided by 2 is a natural number. Or maybe if you take 2 divided 1, so you get 2, it's a natural number. Or minus 30 divided 3, it's gonna give you negative 10, so it's going to be a integer. So we're doing in this part of the track. However, there's a problem. What happened if you use 3 divided 2? 3 divided 2 cannot be expressed as an integer, cannot be expressed as a whole number, and cannot be expressed as a natural number. Okay, in fact, if it cannot be expressed as an integer, cannot be expressed as a whole or as a natural number. So then we have a new set of numbers. This is the set that we call rational numbers. Rational number is any number that you can represent in the form of a ratio. I mean, A over B, in which B should be different from 0. Because if B is 0, we have an undefined division. So B is different than 0, and A and B should belong to any integer. So then you have the rational numbers. So when you have the rational numbers, what we're doing is just getting the division to another level. Obviously, in rational numbers, we have the fractions. But remember that a fraction could be expressed as a decimal. Or some fractions, like 1/3, could be expressed as a repeating decimal. So repeating decimals are also fractions, are also rational numbers. So if you can express a number as a ratio of two numbers, like for example 10 divided 2, so you can say that is a rational number. So this is why 5, it's also a rational number. And finally, what is the next operation that we can see, that we can apply and that we can use in order to understand our number sets? The last operation could be the roots. What happens if we take square roots or cubic roots or any type of roots? For example, we know that the square root of 9 is 3, because 3 to the second power is 9. We know that the square root of 4 is 2, because 2 to the second power is 4. Or it could also be negative 2. We can use negative 2 because negative 2 to the second power is 4. But look at that. There could be a problem, that is, what happens if I want to find out the square root of 2. The square root of 2, if you calculate it, you learn the process to calculate the square roots, you will see that the square root of 2 is going to give a number that is a decimal, that is not a repeating decimal, and is not a finitesimal. So it means that this decimal goes into infinite without repeating the numbers, without having a pattern in the numbers, but without repeating the numbers. So it means that the square root of 2 is something that we call not rational or irrational numbers. So the irrational numbers, it's only any number that we can say that it's not rational. We have the square root of 2, square root of 3, square root of 5. There are two numbers that are pretty cool, and we highly use it in mathematics, and it's pi and the number e. Maybe you have listened to pi when we work with circles to find out the area of the circle, and the number e. Maybe you haven't listened about, but it's a number very used in mathematical analysis and the use of functions. So these numbers are numbers that we use when you have to determine irrational numbers. So when you have irrational numbers, these are examples. Music. So to sum up, we have the set of the natural numbers when we count numbers. We have the set of the whole numbers when we include the zero. We have the set of the integers when we include the negatives, or the opposite. We have the set of the rational numbers that implies the division of two integers. And we have the irrational numbers that are these numbers that we cannot set as the division of two numbers. And finally, this is what is going to get our number set, call it the real number system. So the real number system is just divided with the natural numbers, the numbers we can count, whole numbers that include the natural numbers, but the zero, the integers that include the natural numbers, the integers that include the natural numbers, and the negative, or its opposite, the set of the rational number that includes all these sets, but any number that could be expressed as a ratio, so the rational numbers, and finally the irrational numbers, that are these numbers that we cannot write as irrational numbers. And this is what we call the number system, the real numbers. This is what we call the real numbers. So if you understand what are the sets and which one goes first and which includes which one, what you can do is that when you perform some operations and when you see the answer of these operations, you can think whether the operation is correct or not. So in many places, like for example in technology, when you're defining variables, when you're defining numbers, you need to define a number based on one of these sets. And I hope that this information helped you to understand the hierarchy or the different number sets. And in this way, you can see what is the different types of numbers that we can use in real number system. Have a nice day. I hope you have an excellent day. And if you have any questions, remember to comment, remember to like the video, and subscribe to my channel. See you next time. Bye bye.